about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hi, I'm Leonard Facchinetti, and let's write some code together, shall we? What we have on the menu today is the continuation of the experiment that we started yesterday, and that is to test different approaches to developing real-time audio effects for REAPER. The different approaches are using JSFX only and using memory for the so-called real objects. Fotis and Stuff is here. Hello, great to have you here. So that's approach number one, real objects. And these are objects that you can put in arrays, that you can pass as arguments to functions and that sort of thing. And that gives you maximum flexibility and minimum code repetition. You can treat filters and waveform drawers and all the kinds of components that you would need to process audio in real time and to have beautiful graphics. You can do all of that in the language, but you do need to access memory a lot, which is somewhat slow. Approach number two is the approach that we started proposing yesterday, which is to write a JavaScript program that generates JSFX, gets rid of all the code repetition, but also doesn't use the memory. It only uses the stack. It only has local variables like this. It doesn't ever goes to like a buffer and access memory that way. It doesn't do that. So that's approach number two. And we benchmarked them, and it seems like the thing that we are doing to benchmark is to just run 1,000 filters, a low-pass filter, 1,000 of them in a cascade. And in the version with real objects in JSFX only, the first approach, the approach that we have been following on this stream for like 3 months, 4 months at this point. So with that approach, which is this code right here, the code takes about 25% of my CPU while I'm streaming and doing other things on the machine. So it's not just running 1,000 filters, but it's about 25% of the CPU. And with this crazy approach of just having 1,000 blocks of code that looks like this, and I guess I can show you what the result looks like. The code just looks like this. It's 1,000 filters in a row. That code takes about 20% of my CPU. So that's a 5% improvement, which is not negligible. It's something. It's significant. So that's approach number two. But actually, I forgot to do this yesterday, and I think it should be done, which is approach number three. And approach number three is to not repeat the code like this, but to have a function in JSFX, which I guess is the most common approach people would use. So we would not have this block of code repeating. The block of code is going to be extracted. We will have 1,000 lines of us calling the function, but will not have the repetition of the body of the function. So I actually did 2 optimizations in one pass, and that's what I'm trying to decouple. One optimization is, or not optimization, change, I should say, because I'm not sure that I'm optimizing anything. I'm not sure I'm making things better, but supposing that I am, I'm doing 2 things in one pass here. And I want to decouple this. I want to do this thing separately. Thing number 1 is unrolling loops like this. So taking something that would have been a loop like that, and copying and pasting the code. So that's thing number one. And thing number two is I am inlining the function body. So here is a function call, and I'm taking the body of that function call, the implementation of that function, and then I'm copying and pasting it where it's used. So function inlining and unrolling loops. I'm going to write this down so that you know what I'm talking about. So there are two optimizations. There is the loop unrolling, and optimization number two is function inlining. And I suppose that these are optimizations. I think that these do make things faster. And these are things that a compiler would typically do in your code. If it finds a function call, it may inline that function body in the call. And if it finds a loop, it may unroll that loop. But it only does that under certain conditions. Depending on the size of the function, it's not worth inlining it, because if the function is too big, you end up with your code is just too bloated. And similarly, if the loop goes around for too many times, it's not worth to unroll it. So the compilers that are compiling like your C code, they look at the functions and they have some heuristics to determine if they should inline functions and unroll loops, because sometimes it is advantageous to do that, but sometimes it's worse. And Bo is here as well. Hello, Bo. Hello, Fuzzies. It's great to have you here. And I'm sorry to hear that it's still the same old crap, but we are going to do the same old crap over here, and it's going to be a lot of fun. Hope you like it. So we already have a version of the code that does not do any of these two. Then we will have a function that well, we already have a version that is doing both of these. Let's have a version that is only doing the loop unrolling. But we will have functions in JSFX. We will not inline the functions. Right, so let's get to that. Well, first of all, I moved things out of my REAPER configuration folder because REAPER was finding thousands of files in there. Now that we are using JavaScript, we are using node modules, and there are thousands of files in here. REAPER was picking all of them up as JSFX, and naturally they're not JSFX. So I moved everything out of the REAPER configuration folder, but I didn't change the code to put the generated effect in the right location. So let me go ahead and do that real quick. I am going to go to my REAPER configuration. And then into effects, and then into my development folder, and then I think I can drag and drop this, right? No, it opens the folder in Visual Studio Code. That's not what I wanted. If I copy and paste, if I copy over here, not copy the name, but copy here, and then paste there, nope, doesn't work either. I'm sure that if I drop it on the terminal, it works. So I'll copy and paste from the terminal. Okay, so this is going to put the file in the right folder. In fact, the folder is empty now. But as soon as we fire our, I need to be in the JSFX folder, and then when I npm start, the file appears there. And in REAPER, when I refresh, and then we'll have a stress test JSFX. Great. I suppose I can remove it from here. Also, I probably will want to run this at some point, but I'm going to try to not run this often because I know it's going to glitch my audio on the stream. But yeah, let's write another one. So this is with function inlining. Let's write another one that is without. And now over here in REAPER, when I refresh, I will see two plugins with function inlining. Probably can remove this one. Yeah, let's remove that one. Show resource path. I should have done that before, right? There you go. All right, so we are going to start the version without function inlining in a moment. But before, I want to read what you all are saying in the chat. In the movie 2001: A Space Odyssey, the HAL 9000 stands for Heuristically Programmed Algorithm Computer. I didn't know that. Yeah, COVID sucks. Sorry. Fans noticed that if you shift HAL one letter, it becomes IBM. I didn't know that. I thought the lore that I heard... By the way, why are we here? Oh, we are here because of the word heuristic. So the lore that I heard is that they wanted to use IBM in the movie or the book. The movie and the book have been written at the same time, right? So the lore that I heard is that they wanted to use IBM, but IBM didn't let them, so they went for HAL. Who knows? Right. So many of the things that we want to do are going to be similar, except that this with function inlining situation is going to be changed into without function inlining. And now, when I refresh this, I have two versions, with and without function inlining. Now, let's have a function in JSFX, so you have to keep track of things, right? This is JavaScript, but when we use the backtick, we are into JSFX land. So we are going to have a function that is going to be called filter. It's going to receive as argument a sample. Yeah, okay, all that makes sense. Then the body of the function is similar to that, except that v0 is sample and this is just my output, so I guess I can just do that. And then instead of having this local thing here that is part of my loop, doesn't really exist at this point, instead of doing that, what I will do is I will say this dot. And, oh, but not for all of these. Oh, yeah, for all of them. Great. And then to use the function to filter stuff, I will have a loop that looks like this. Instead of calling this the local, I guess... Because I'll just have an index here, at least to begin with. So now, I guess I'll say absspl0 is equal to filter dot, no, not filter. Filter is the name of the function. Maybe we'll call it filter sample. Whatever. So I'll have a filter and then an index and then filter sample, and I'll pass spl0, and that is going to loop around. So I think this is all we need. Let's check the code that was produced. I'm going to add a folder to my workspace that is going to be the REAPER folder. Oh, it was already on my screen. Okay, so this is what it looks like. And in case you are new to this whole namespacing thing, the pseudo objects approach, we discussed this, but we never really used it a whole lot. The way this works is you can pretend that this variable is a namespace or a pseudo object, and this is kind of a method or a function on that pseudo object. And everything that has this dot in the beginning is going to refer to variables in this namespace. Right? So that's the way that this works. And this is the approach that most people use when writing JSFX. Now, how about we start with a single filter to see if our code even works. Let me remove the outputs from this REAPER instance, and we are looking for the version without function inlining. Let's drop a track in there and put this effect in the track. Then two Burton EQ analyzers. Put my effect in the middle, and we should be seeing something here, but we are not. It's saying that the track is bypassed, but if I enable it for recording, there you go. Okay, so the filter is working, the effect is working. And if I just increase this number, I think that we are going to see the result of this. We are either going to see a performance improvement or not. So if it is around 20%, it's about the same. If it is better than 20%, I will be surprised. And if it's around 25%, accessing memory and using pseudo objects is kind of equivalent. My audio is probably going to glitch now, so stop speaking, but pay attention to the CPU usage in REAPER. Just to confirm the audio is right. Yes. Okay, my audio should be back. According to my meters, the audio is okay now. If you can still not hear me, let me know. But it seems like it's around 20%. So the version without function inlining seems to perform about the same as with function inlining. So now it is more like it's not a performance thing, it's more like a expressiveness thing. Do we prefer to have the pseudo objects then use functions in JSFX, or do we prefer to do everything in the JavaScript part of the code and inline everything and then have code that is a lot bigger? I think I prefer to avoid the pseudo objects in JSFX because they are kind of hard to wrap your head around. I don't really like the way that they work. And it's one more layer of complexity. I think it's better to just inline everything, but at least we got that out of the way. Let me remove that just to make sure. But I wasn't saying anything, but I think you caught that the filter was working right. It became a lot steeper when I increased the number of filters to 1,000 filters in the cascade. So that covers this, the loop unrolling kind of thing, the testing of pseudo objects. Now let's go to the topic of this stream, the title of this stream, which is to draw waveforms using variables instead of memory. So let's dive into that. The second kind of stress test to see if this approach, the JSJSFX approach of JavaScript generating JSFX. So we'll see if this is going to fly or not. The stress test is to do the drawing of waveforms. So I'm going to come up with a different plugin And I'm going to call this LEAFAC stress test waveforms objects. This is going to use my library. So I better have it here, right? Let me copy that over. Okay. And then in the init block, we need to initialize the library. In the sample block, we'll need to collect samples. And in the GFX block, well, I don't really care. It is kind of silly, but the stress test is only about the collection of the samples, because the GFX block is the one that is actually drawing the waveforms, and this one is just collecting samples. But in the GFX block, we are running this block a lot less often, about 30 times a second, or in the upcoming version of REAPER, we'll be able to set up the frame rate. So we'll be able to go to 60 frames per second, which is great. But we are not there yet. So even then, 60 times per second is a lot less than 48,000. So this is not going to stress anything. And I think that the CPU meter over here doesn't even count the GFX block. I think it only cares about the processing of the audio. So I'm only going to stress this part of the library, and that actually makes things a bit easier for me, because I will write less code on the other version in JavaScript. Right, so let's go to the demonstration effect, or even the volume plugin, doesn't really matter. And I'm going to copy the code that is necessary to initialize the data structures. I am not going to have one per channel, however. I am going to just have Waveform Scout. So let's say that I'm going to store 100 of these waveforms, which is somewhat realistic. We can increase this number if necessary to really stress test this, but storing 100 waveforms, suppose that you have 10 instances of the plugin and each one is drawing 2 or 3 waveforms. That's already like 60 waveforms to store. Now, naturally, we can prevent the sample block from collecting samples when the graphical user interface for the effect isn't open. In fact, we should do that. This is a stress test after all. And the main point of this stress test is that the waveform thing is a circular buffer. So in the memory version, this version that we are implementing, the circular buffer is a big chunk of memory and a pointer that goes around that chunk of memory. And in the JavaScript version, the one that is going to unroll this, we are going to do something similar to the ReEQ plugin, where let me open another folder into this workspace. That is going to be the whole effects folder. In fact, I think I can remove this one. And let me find ReEQ. And check this out. This is a circular buffer that is done with just variables. So it's reassigning all the variables. And that's what we're going to do in the JavaScript version. But we are not there yet. So we are going to replace this, and I'm also going to replace that. And there's something else that I want to mention. I established this naming convention where variables are namespaced with the block where they appear. So if it's a variable that only occurs in the init block, I say init dot in the beginning. If it's a variable that appears in multiple places, like in the init block as well as in the sample block, then I prefix that with instance. And variables that only appear in the sample block are prefixed with sample and so forth. And the reason why I established this naming convention was so that blocks of code that run at the same time, like the sample block and the GFX block, can have variables with the same name, but they're going to be under different namespaces. And that's important because I do looping over the channel over here on the sample block, but I also do looping over the channels in the GFX block. And if the name of the variable is the same, the variable is shared between the two blocks, but they're running at the same time. So you run into issues where the variables start stepping on one another, go out of range, and all sorts of bad things happen. But what I realized is that having the namespace everywhere is kind of a lot. It makes everything even longer than it already is. I have long variable names everywhere. And it can become too noisy and kind of hard to read. So what I realized is that, well, what if I just namespace the GFX block? I think that's good enough, because as far as I understand, the only blocks that run concurrently is the sample and the GFX block. Maybe the slider block also runs at the same time. I'm not really sure, because it's kind of hard to test. And I know for a fact that the sample block and the GFX block run at the same time. So maybe we will need to prefix stuff in the slider block as well. But I think that the main thing is the sample block, right? I think that the GFX block probably has more variable names, but if you think about the naming convention of JSFX itself, then functions that, well, I don't have an example here, but functions that run over samples are like FFT or seal, and GFX functions are always like GFX line 2 and so forth. So the main convention is already to prefix stuff in the GFX block. So I decided to drop the namespace from everywhere except the GFX block. That's why I'm removing the namespace over here. We'll see if that's going to work. So I don't need this namespace as well. And then we'll just have a Waveform Scout. I guess I will use a dot to separate. And then instead of channel, I'll just call this index. And then I'm going to store 10,000 samples, 10,000 slices. And each slice is going to collect 5,000 samples. All right. Then in the sample block, I will do the collection. So let me find the sample block and then the loop where I store stuff in the waveform. So that's here. And then all of these are going to become that. And instead of the number of channels, we'll do the Waveform Scout. And then this is not related to the waveforms. This can be renamed into waveform. And this has been renamed to just waveforms at, I'm going to call this the index. Oh, there is another thing here that will be potentially slightly faster. Accessing samples this way, at least it says so in the documentation. In the documentation, it says that accessing samples this way is slightly slower than accessing them this way. Is that still the case? It used to be the case. Yeah. SPL 0 is generally faster than, slightly faster than SPL parenthesis 0. So because we are copy and pasting code, we'll not need to use the parenthesis version in the crazy JavaScript loop unrolling thing. Right, so I think that this is all, but before I review it, let's see. I should make an electro rock band called the Circular Buffers. Yeah, I mean, could you please explain what garbage collection is in programming? I've heard that Ruby language does it. Sure, yeah, it's a tangent. It's not really related to this, but In a way, it kind of is. So garbage collection has to do with memory management. And we are using memory, right? We are allocating memory to store stuff, and we are using memory or pushing stuff into memory like that. So because we are doing real-time audio processing, we are not really required to, but it's a best practice, and you should do it this way. You allocate memory only once, and then you use memory in the audio thread, in the sample block. But you don't allocate memory there. You don't say .new there, ever. The reason is you need to ask the operating system to allocate that memory, and that may block, and if things are too slow to release the block, then you're going to drop some frames. You're not going to compute the sample in time, and you're going to hear a click. So that's the allocation part of memory management. And in JSFX, what we tend to do is just allocate memory, and we never release memory. We just pessimistically allocate as much memory as we think we are ever going to need. So for instance, for my waveform display, I allocate 10,000 slots, even though 10,000 slices, even though no monitor has 10,000 lines. No monitor has 10,000 pixels wide. So I'm just storing things pessimistically. And I never release memory. And that's kind of okay, because I am not needing, at least not in these simple effects that we have been working with, I'm not needing to create new data structures. But there are some cases where you maybe would need to do that. Think about ReEQ, for instance. ReEQ has this super interesting feature that I don't think any other EQ plugin has. You can add arbitrarily many bands. And of course, the graphical user interface here is going to start acting weird. But you can use these bands. Even though the graphical user interface is kind of weird, you can just keep adding them. See, I'm clicking around, I'm adding bands, and it never stops. I don't think there is a limit to this. Maybe it stops at 64 or something, but suppose that it doesn't. Suppose that it does not stop ever. So the way that this works is it's allocating memory as you are using the plugin. Now, of course, you can sort of do that in the slider block. You can think of memory as being allocated when you are changing parameters. And that's similar to initialization, because you cannot really automate the creation of bands. You can always automate the frequency, the gain. Maybe you could even automate the type, not in ReEQ that I know of, but you could automate the type on a morphing kind of filter. But you cannot automate the creation of bands. But suppose that you... So this is us allocating memory in the slider block, which is pretty much equivalent to allocating the init block. But suppose that you need even more flexibility. And I don't think I can give an example of that using audio effects, but when you're doing like web programming, a request comes in, you need to allocate some memory to store some user data, or you are doing a desktop application and someone opens a new window, and you need to allocate the memory to show that window to the user, right? And things are popping in and out dynamically. Sometimes a user creates a window, sometimes they destroy a window, and sometimes they send a request, and sometimes the request is over. You answered the HTTP request. So in these contexts, it is necessary. Oh, look at that. I'm doing that in the input effects. I thought I was doing that in that part of the effects chain. This is my voice. All right. So that's why I had to enable this for recording. So that explains the necessity of allocating and then destroying objects, right? Sometimes a request comes in. Sometimes a user creates a window, that sort of thing, which I guess is more flexibility than you typically have from your audio plugins. And in fact, this whole conversation is why most audio plugins do not allow you to have infinitely many bands or arbitrarily many bands. Okay, so that's the necessity of allocating and destroying memory, or freeing memory, if you will. But then the question is, who is in charge of this? Who is taking care of allocating and then releasing memory. Depends on the language. If you are doing JSFX, there is no way for you to release memory. Well, kind of there is. There is this thing about JSFX that is under the memory thing. It's called free mbuff. So you can release memory that way. And you are in charge of this. You are taking care of memory and you are the boss. You have to know that you are not using that memory anymore and you have to release that memory. So if you have that ReEQ kind of thing where you are allocating memory in the slider block because you have infinitely many bands or arbitrarily many bands, then if you delete a band, then you should call free mbuff to release that chunk of memory. And you are in charge of doing this. And in some languages like C and C++, and Rust, and, well, many other languages, you are in charge of doing that. You have to allocate memory and you have to release memory. And for instance, REAPER is written in C++. So the developer of REAPER, Justin, has to allocate memory when you put when you create a new window, and he is in charge of releasing the memory when that window goes away. But if he does anything wrong, if he, like, for instance, tries to use a window before it has been allocated, it sends that window to be rendered before it has been allocated, or if he releases that window after the window has been destroyed, he releases that window, but then tries to send that window to be rendered, that's going to blow up because you're just going to get junk in that piece of memory that where used to be an object, or that memory used to be a window. Now it's nothing, and you're trying to render nothing. It's going to blow up. So Justin is in charge of allocating and releasing memory for REAPER, and that's a difficult thing to do. Many bugs arise from this. And in general, you have to come up with all sorts of strategies to manage memory in a way that will not run into these issues. Now, there are languages in which the developer is not responsible for allocating and releasing memory. The developer can say, I want a window to show up, and then the window is going to be rendered on the screen, and then when the user destroys the window, the language is going to see, oh, okay, so this window has been destroyed. There are no references to this window in the code anymore, so I can go ahead and release that memory. I can free that memory. And the programming language does that automatically. Not necessarily the programming language, but the runtime that comes with the programming language does that automatically. And then this is called garbage collection. Garbage is any chunk of memory that is no longer accessible by the program. For instance, say that I have a variable here called hello. The init block runs, and then it's not going to run again. So this hello variable is not used anywhere in the program. So this number one, well, it's not really an object, but suppose that this is like a window kind of thing. This window is no longer accessible in the program. We know that we'll not run this code again because the init block only runs once. It has already been run. This window is garbage. It can be released. And if Justin forgets to release that window in C or C++, that window is going to occupy some space in memory. And if you happen to do that in a loop, it is going to leak memory, so to speak. That's the term that people use. That it's going to leak memory. It's going to consume memory for no good reason, which is a bad thing. So if you forget to release memory that you should, that's a bad thing. If you release memory that you shouldn't, because you're still going to use that window somewhere, that's also a bad thing. And it's difficult to get this right. So that's why garbage collection exists. This hello variable became garbage after the init block has run. So the garbage collector can detect that and get rid of the window automatically. Now, it's still possible to have memory leaks in a garbage collected language. It's not a perfect algorithm. There are always ways for you to fool the garbage collector. I guess this ties back to what I was talking about yesterday. If you have a Turing-complete language, there are some things about the program running that you cannot determine. It's just not possible to do that. It's not that we don't have enough computers to do it. It's not that we don't know an algorithm to do it. It has been mathematically proven 100 years ago that it's impossible to do it. So what happens is, in a garbage collected language, there's still ways for it to leak memory, but the garbage collector works 99% of the time super well, no memory leaks, and the programmer has to think a lot less about memory management. So most programming languages that you use these days are garbage collected. Let's go to the Stack Overflow. I really like this survey. They do it every year, and they ask people what programming languages they use. So JavaScript is garbage collected. Or there's actually a nuance here. JavaScript is a language, but a language is just a language, right? You need a runtime for that language. And in the browser, you have a runtime that runs JavaScript. And in my machine, I have Node.js running that runs JavaScript. And all of these are garbage collected. You could come up with a variant, a runtime for JavaScript that is not garbage collected, or you could come up with a variant of C that is garbage collected. But typically JavaScript is garbage collected, and typically C and C++ are not. But HTML, CSS are not really programming languages. They're it's hypertext. What is HTML? Hypertext markup language. Is a markup language. SQL is a query language. Python is garbage collected. TypeScript is a variant of JavaScript, garbage collected. Node.js, JavaScript, garbage collected. Java and C++, garbage collected as well. Bash, I don't know, but probably garbage collected because, yeah, it is garbage collected, I suppose, by the operating system, because the operating system is going to get back the memory from the processes that have run. PHP is garbage collected. Then C and C++ are not. PowerShell, yes, it's similar to Bash. Go is garbage collected. Kotlin is a variant of Java, is garbage collected. And when I say a variant of Java, I mean that it runs on the same runtime. Ruby is garbage collected. Rust is not. Dart is garbage collected. So you see, most languages, most modern languages are garbage collected because garbage collection solves lots of interesting and great problems. But for real-time audio processing, you don't want garbage collection, because what if the garbage collector has to stop the execution of your program right here in the middle of the audio thread to collect the garbage? Then you're going to drop some frames because you don't have the time to compute what the next sample is supposed to be. So garbage collection is great, but for real-time audio processing, you probably don't want it. For the GFX part of the code, you can have it. It doesn't hurt. All right, so that's the tangent. Let me report this person real quick. Been getting more of that lately. Interesting. Right. Yeah, so you heard it right. Ruby is garbage collected. Most languages are, but C and C++ and JSFX are not. Yeah. Will the length of the variable name affect the performance? I don't think so, but it's something we can test. But no, I don't think so, because the length of the variable is abstracted real quick in the compiler. I mean, JSFX is a compiled language, so all of these become just a name. Like internally, what the compiler is going to do is going to see, oh, okay, this is a variable. I'm going to call this like variable number 1, and this is not really a number, it's just variable number 1, and then it sees that and it says, okay, this is variable number 2, and so on. So very early in the process, the lexer and parser in the compiler are going to abstract this away, so I don't think that the name is going to affect the performance. It's going to ever so slightly affect the performance of the lexer because it needs to lex or make sense of more characters, but it's negligible. Lexers are like linear in time. It's absolutely super fast. You never have to worry about variable names being too long. Thank you for the explanation. You are very welcome. I really need to watch your FFT series. You are in for a treat. I'm very proud of those streams. Very happy. All right. If you have follow-up questions, make sure to ask. But we are back from garbage collection into this piece of code, which is definitely not garbage. So let me see if I'm missing something. Let's review this. Description, we import a library, we initialize the library, we have a counter, we go over that counter with the index, and for each position we store one waveform. Then in the sample block, we do the same loop, and we push into the waveform. Oh, I'm missing one thing. That. So I'm going to go into there, and then I'm going to store, well, no, not really. I shouldn't store the sample at index. I should store sample 0. This is not multi-channel anymore, so I'm just going to store the left sample everywhere. All right, so this is supposed to work. Let's drop it in REAPER and see what it looks like in terms of performance. Oh, I need to scan for new plugins, and my audio may glitch now. Let's see. Okay, I don't think my audio is glitching because 3% is not a big deal. Let's crank this up. I got the beach ball, but it seems like my audio isn't glitching. Oh, it is glitching. Got the beach ball. And REAPER crashed. Okay, so storing 1,000 waveforms is not making REAPER happy, but I think that my voice is back, right? So 1,000 is too much. Okay, how about 500? Maybe how about 200? Let's be conservative here. Just double checking that I'm not accessing memory out of range, because if I am, then I will reach that. Yeah, glitches and beach balls, yes. I want to make sure that I'm not accessing any memory that is out of bounds, because if I do, then we'll run into that ARM bug that we reported last week. Let me double check. Yeah, all of this looks good. And the version with 100 was working, so it's probably just the number being too big. Let's open REAPER again. Take out this output, and yeah, I guess the lesson is don't try to use the machine that you are streaming with to do stress tests. That's a silly idea. Okay, I don't think my audio is glitching right now. 6% is okay. Let's do 500. And we got a crash. Okay. Maybe 500 is too much. Oh, you know what it could be? It could be the out of bounds checking issue, because we have 500. We have 500 of these, and each of them is taking 10,000 places in memory. That is 5 million. We have 8 million slots, so that shouldn't be an issue. But whatever, we'll go to 300. and open REAPER again. Three 300 crashed REAPER. We are crashing REAPER a lot lately. Okay, this is as good as it's going to get. I don't think that my voice is even glitching, but we are getting about 12% CPU, which is not negligible. So I guess this is a good enough stress test. And we remove that to make absolutely sure that I'm not glitching. But yeah, so it seems like 200 is a good number. And then we are going to re-implement this using the copying of variables, essentially this approach, and we'll see. Yeah, okay, my voice is not glitching. Thanks for letting me know. Streaming and stress testing at the same time is a stress test of its own, but yeah, you need the full CPU power for an accurate stress testing without streaming. Yeah, I did that after the stream yesterday, but the results were similar, so I'm not worrying about it. I guess my CPU is not prioritizing the stream. It's just letting things glitch in the stream. The audio, mostly. I don't seem to have dropped frames in the encoding that goes to YouTube. So I don't think that the video is glitching, it's only the audio. Whatever. So let's re-implement this real quick. So we'll start with these lines. The cool thing about having something that runs as soon as you save is that you, for instance, right now I cannot save, or these two are going to overwrite. I need to rename the file first. So where is my file? It is going to be called that. And then we already have something over here. And it's empty. Great. I'll in fact have that open. So in the init block, I don't really need to do anything. Great. In the sample block, I will need to loop with something similar to this. And this time I don't want to loop 1,000 times. I want to loop 200 times. And this is going to be the waveform index. And what I want to do 200 times is to push into the waveform circular buffer. Let's see, ban the circular buffers. Is the name already taken? It's not. The circular buffers. Namecheap.com. Circular buffers. Circularbuffers.com is available. Check this out, Fatis. Check this out. Okay, what do we want to do 200 times? We want to store SPL0 into the circular buffer. So the circular buffer is 10,000 samples in size. Yeah, awesome. It is available. So we'll do a loop that is similar to this but it goes around 10,000 times. And I have a syntax error of some kind. Well, no wonder, right? I'm popping in and out of JavaScript and all sorts of weird ways. Sometimes syntax errors happen in this case. I think that these are extra. Yeah, got it. So this is not the waveform index, this is the slice index. And then what do we do? Well, let's do the shifting of the whole window. First of all, let's do the easy part. We'll do the waveform.slice.0 is SPL0. Yeah. Or actually, I'm going to say that this is n. So this is the waveform at n. But before we do that, we need to slide the window. Oh, and actually this we don't do in this loop, we do outside this loop. Over here. Oh, and I need to have the waveform index over there. And then we'll do something that says the slice index I think that this is going to do the shifting of the window. Let's see. I'm not getting anything. Oh, the app crashed. Where? Waveform index is not defined, but it should be. So I am in the wrong part of the loop. There. Okay, now I'm getting something. Oh, hang on. This file is big. This file is big. Is my voice glitching now? It could be. Visual Studio Code is not too happy. It's trying to syntax highlight this. And this is a big chunk of code. Oh, this is not correct. We don't want to do that. Ooh, yikes. Visual Studio Code is super sluggish. How about we change this into text, plain text? Because it's not such a huge file, is it? It's only, what? It's only 6 million lines. Yeah, thanks for letting me know. Now I am worried about the glitches. It's only 6 million lines of code. It shouldn't be too much. Right? So this first one is incorrect. We shouldn't be starting at 0. It's more something like this. Visual Studio Code is not having a happy day here. Come on, Visual Studio Code. It's 6 million lines. Don't embarrass me in front of my friends. This window is not real. Okay, close. At least the whole app didn't crash, which I guess is a good thing. I closed it anyway. It's gonna retry, and this time it succeeded. You know something that could make things a little bit better, maybe? If I did it in a single line instead of having new lines here. And I still don't want to start at 0. Oh, you made REAPER crash? How so? What did you do? I guess what I want is the indexes to be different, so I don't want to do this 1,000 times. I'm going to subtract 1 because 1 is this, right? Okay, so the intent of the code that I'm writing is slice at n minus 0 is SPL0. And then, but before we do that, we need to take care of everything else. So I think I want to do this in reverse. You know what? I'm going to bring in low dash real quick to make this code a little bit better to read. So I need to go into the JSJSFX folder and install low dash. Then I need to import low dash from low dash. And then instead of having this crazy thing, I can do low dash. I'm not going to do it here. This one is working. I'm going to do it here. So let me remember how to use low dash for this node. Const low dash is await import low dash. Low dash, I think it's range. No, it's not. Oh, it's going to be low dash default range. Yeah, that is a function, so it can go from 1 to 10. It's not inclusive. So, okay, I think that's all I need. So low dash range, not random, range from the waveforms are going to go from 1 to, how many did we have? Oh no, I opened that buffer. I cannot open that buffer. 200. So I want to go up to 201 because it's not inclusive. And on this one, I will do low dash range from 1 to 10,000. Oh, I need to stop opening that file. So what I want to do is actually to go the other way. Can I do from 10 to 1? Not inclusive. So I need to do 1 fewer. Great. So I'm going to go from 10,000, or actually from 10,000 minus 1 down to 0. And then I can do it the way that I wanted to do in the first place, like that. Okay, how about we do this with smaller numbers so we can open this file without fear. And it's already an example of something that I want to bring into this JSJSFX approach, which is to use abstractions from JavaScript. I'm not defining a JSFX variable, I'm defining a JavaScript variable. So I will do waveform, what was it called? Oh, I opened the file. I shouldn't open that file. I opened the file, Waveform Scout. Waveform Scout is equal to 200. And this, I guess, is the slices count is equal to 10,000. And this is that. Great. So now I can have just 2 waveforms with 10 slices. And then I can open this file without fear, because it's not going to be too big. Come on. Oh, I'm not running npm start. Okay, now this is a relatively small file. So let's see if my logic makes sense. Not really. I want n-9 to be n-8. So this is reversed. Yeah, n-9. Oh, see how snappy that was? Great. So n-9 is n-8, n-8 is n-7, and so on up to n-0, which is SPL 0. And then I do that over again. Okay, that works. Let's load this in REAPER. Oh, not that one. Not that one. Scan this. Oh, this is liafak. Isn't that something? Okay. Waveforms with JSFX. And naturally, this is not going to take too much CPU. Oh, it may. 1.4, and we are not even using big buffers. Yikes. And there, actually, my other version is doing a bit more logic over here, because it is... Oh, yeah. So my other code, my version using my library, is accumulating samples. It's accumulating 5,000 milliseconds, so 5 seconds. It's accumulating 5 seconds worth of sample before it slides the window. So this is not really a fair thing to do. I need to check if I must slide the window. So I already have the code that slides the window, but I need to check if I should slide the window. So we need a counter. And then we need to check the counter. And I need to do this in the JSFX part of the code because it needs to be aware of the sample block as it's running, right? I need to know which sample I am at runtime, not at compile time, so to speak. So I need to check if my counter is equal to 500 milliseconds worth of samples. So it's not 5,000 actually. So this is going to be the duration. 5,000 milliseconds, and I'll define a function real quick. Milliseconds to samples. No, I cannot. Well, I can, but I won't. I'll just have a 5,000 times the sample rate, or divided by the sample rate. I always get this wrong. It's the sample rate divided by 5,000. And again, I need to do this in JSFX because only in JSFX I'll have access to the actual sample rate that you have. So I guess this is something that I should do in the init block. This is the samples per slice. Let's see if this checks out. 48,000 divided by 5,000. No, is it that? Oh man, second guessing myself. Yeah, it's 5,000 milliseconds to samples, and let's check the implementation of milliseconds to samples. Milliseconds to samples. Yeah, I got it wrong. Yeah, so 5,000 milliseconds turned into samples. Okay, I think that this is right now. So now I need to check. I increment the counter, just for good measure, since now I have a init block. I'm gonna have that. So it's gonna start at -1. So the counter starts at 0, goes up to this number, and I'm gonna check. If it is equal to that, then I need to shift the window. So I just bring in this, that shifts the window. So this is a better thing for me to do first because it's more realistic, similar to the code that we wrote before, but also because I was shifting the window too much. I was shifting the window too often, which cannot be a good thing. It won't be a fair thing. Shifting the window is expensive. It is hundreds of assignments. So if I don't need to do that, what do I need to do? Well, I need to wrap the counter around, and I'm going to accumulate something into this. I don't need that. And I was accumulating with maximum. Oh, there is another wrinkle. I was storing 2 values in here, so I guess I will store 2 values in here as well. Maximum. As well as the minimum. And then naturally over here, I also need, hang in there. Let's do this first. What happens when I am resetting the window? I reset the counter. I go over all the waveforms. Over the slice. And I need to reset. Okay. So to reset, I just set the maximum to a really small number and the minimum to a big number. And I suppose that I need to do this to begin with as well in the init block. So we might as well just do this differently. I'm going to start at -1, this counter. So the first time around, it's going to be 0. So I can check for 0. If I am 0, then I do this reset. And then I can do it in a single place, which I guess is a smart move. Otherwise, I am going to... Oh, and it's only then that I'm going to slide the window. Come on, Leandro, it's not that difficult. Okay, the counter starts at -1, then I start by incrementing it and I check if it's 0, so I'm just starting things. And to start things, what I do is I slide the window, then this doesn't happen. Where is my big number? Oh, I got rid of that. None of this happens. The maximum is a small number. The minimum is a big number. Okay, I finally got it. So starting the counter at -1, incrementing 1, the first time is going to be 0, so I need to reset. To reset, I loop over all the waveforms and I do the shifting. So for each one of the waveforms, I slide the window. And to slide the window, I'm missing something. I need to slide both the minimum or the maximum as well as the minimum. All right. So I slide it. It seems when I get to the waveforms, it seems like I always get confused. It's really hard for me to write this kind of code, and it's not that difficult of a code to write. It's just that I have issues doing this. In fact, there is this funny comment in my original stream implementing the waveforms. The guy says, "How about you learn how to do the thing and then you stream about it?" I'm trying to. Okay, so to reset, I slide the window. And then I reset the values. But if I am not resetting this, then I need to essentially do this. But I need to do it for every waveform. So let's do this, and then that, and then the other thing. Yep, I'm just accumulating that into here. And then the maximum is with max and the minimum is like that. Then I also need to check if I need to wrap around. I'm going to do a conditional over here. And this is going to be the body of the conditional. This may not be the fastest way of implementing this in terms of performance, but I think it's good enough. What is the condition? The condition is that the counter is equal to the number of waveforms per slice. Yeah, I'm confident that this isn't the best way of doing this, but whatever. Let's review. But before, I'm going to see what you all are saying, and then we are going to review, and then we are going to run this, and it's going to crash REAPER, and then we'll be on our merry way. Thanks for spamming my channel. And I was using oversampling with a high sample rate. I wonder if rate brain was the cause of the crash. How high of a sample rate? By the way, I'm doing something fun in sound design. I'm using a random number generator to pick values for pitch shifting each waveform. Sure, it's better when you stream and learn at the same time. It depends on the stream. The FFT one, I did a lot of research before getting into that, so I do a few mistakes probably, but not too much. And then this one is just me figuring things out. This stream today is more exploratory. Let's have it full screen. Wow, at what rate every sample? Yeah, you probably don't want to do pitch shifting changes every sample. 16 times over sample. Oh, okay. That's a big sample rate. That explains the crash. But 16 over sample is not unheard of if you have a 48K signal and you are doing some crazy distortion, right? I think that all my plugins go up to 8 times, but going 16 is not the end of the world, I don't think. Right, so we are working with small numbers, so I should be able to save this and take a peek at what it looks like. So first of all, the number of samples per slice is okay, that makes sense. Then this makes sense as well. And then if the counter is 0, then I am shifting the window. That looks all right. And I'm resetting N0. That makes sense, right? I just shifted the window, so N0 is now taken. It's now available, so I reset it. And then I do that for all my 10 waveforms. How many waveforms do I have? 30? All my 30 waveforms? How many waveforms do I have? 200. Okay, I am going to decrease this number. Just 2 waveforms. Okay, that's better. Then, so that was the resetting, and if I'm not resetting, then I am going to accumulate samples into those places. That seems to work. Yeah, it seems all right. And then I'm checking if I need to wrap around. I may be one off in this computation, but that's okay. And then it's going to reset the counter to -1. So the next time it goes around, it's going to be 0 again, and it's going to slide the window, and always going to be happy. So let's load this into REAPER. JSJSFX, drop that, and I don't expect the CPU to be too high because I only have 2 waveforms. That's all right. So now we are going to get the big numbers, and REAPER is going to crash, and we'll be done for the day. Before I do that, I want to make sure that my code is doing what I expect it to do. So I'm going to drop this here again, and I'm going to enable this for recording so that I'm really storing samples into the waveform. And I guess one of the advantages of doing this without memory, so I guess another advantage of doing this without memory, is that I can see the variables as they're coming in. Does this look right? Not quite. Yeah, these numbers are stuck and not updating. Is the counter doing the right thing? Yes, it's going up to that number and then wrapping back. But it seems like it's too many samples per slice. I think that this computation is wrong. Yeah, it's getting too many samples per slice. That's why it was okay. Yeah, the code was all right, but it was not wrapping around as often as I expected it to. So this number is wrong. The number of samples per slice is wrong. Boy, this is such a hard thing for me to understand. What am I doing wrong? That's this number here, right? It's 2400,000. That's not the right number. It's not the right number. Let's get into a terminal and start manipulating numbers until I get the right number. If I want to have 5,000 lines. Oh, I know what I'm missing. In the library, this computation is all right. This is getting me the number of samples per 5 seconds, or I guess, yeah, 5 seconds. But what I'm missing is in the computation of the waveform itself, when I'm starting this, I do some computation there, right? I divide that the duration by the number of slices. So how many slices do I have? So this is the duration in samples, and I divide that by the slices count. Now it's 24,000 samples per slice. That makes a bit more sense. Every half second, essentially, I am storing a new slice. And the numbers are going through just fine. Do we see them sort of moving? I was expecting them to move down. Can we follow numbers going down? I think so. I feel like this number is still wrong. Let's go to the other version and peek at that value. Unfortunately, that is going to be hard. Because it's in memory. But okay, let's just go with this. Okay. So let me take out the effect. It's not on the track. I believe the code is doing what it's supposed to. And now we are going to have a big file. Oh, it's closed. Yeah, this file. It's going to be a big file. How many lines in the file? We are at 8 million lines. And let me react to what you all are saying in case my stream goes down when I stress this. That's exactly what I'm doing, crazy distortions. Yeah, right. So yeah, let's crash REAPER for a final time. Oh, syntax error. At sample 10. But if these numbers are smaller, then it doesn't crash. So there is no really a syntax error in my program. Is probably that REAPER has a limit to the size of the effect that it's willing to parse. Yeah, that works. So let's see how far I can go. When I get to 200, can I get to 100? Can I get to 200? Check this out, 200 is not a big deal. And this is already a big program. How many lines of code do we have here? 81,000. This is not a small file. 81,000 is a big file. And it's handling it just fine. Very small CPU use. Great. Let's do 1,000. It is going to crash, isn't it? Nope, it didn't crash. I clicked on... My voice is probably glitchy now. Yeah, it is. All right. I think I'm not glitchy anymore, and REAPER didn't crash. But it was painfully slow to open that edit window. It wasn't too responsive, but it didn't crash. So that's good, actually. And the CPU use was about the same, but we are an order of magnitude away from the number of slices. But the cool thing is that the number of slices does not determine, oh, it does determine, it determines the size of the window shifting. So yeah, if you increase this back to 10,000, then REAPER is gonna just refuse to load. Yeah, syntax error. Refused to load. So yeah, I guess my voice is okay. And what we learned is that for relatively small windows, like in the ReEQ implementation, the window is 64. So for small windows, we can measure this, but Justin said that this was faster, doing it like this instead of doing it like that. So for small windows, it is worth doing all of this by hand. For bigger windows, like this, it's not worth doing that. You're better off using memory. If only because of the load time. We could see that when I dropped the effect on the track, REAPER was stalling for a solid 3 seconds. So yeah, having code that has, how many lines of code does this have? Yeah, if we have 8 million, if we have 8 million lines of code, then you're better off not moving the window by hand. You're better off using memory and a pointer into memory. So we learned that. But what else did we learn? We learned that this approach, it doesn't look too bad. In fact, I mean, I'm aware that there is a lot of complexity here, but we can abstract this kind of complexity using JavaScript. And this kind of code doesn't look too bad. It may even look better than the kind of code that we were writing like this, just a wall of text of me indexing into data structures. So let me know what you all think, if you all think that this is better or if you prefer that, because in terms of performance, there is no free lunch. Doing 8 million lines of code is not going to get better performance. And in terms of performance on the other example, where is it? Oh, I already closed it. But in terms of the filters, the performance improvement was about 5%, from 25 to 5%. That's what we were able to get. So now you know what the performance improvement is, and you know what the limitations are. What do you prefer? Do you think that we should write code that looks like this? Do you think we should write code that looks like that? I don't know. We'll figure this out. You're discovering both the powers and limitations of JSJSFX at the same time. Yes, but this example was silly, right? It was taking it to the extreme, and maybe we would be surprised to find that the extreme is actually a good thing, but I wasn't really thinking that that would be the case. I was kind of expecting that this was going to blow up, but it was fun. We did a program with millions of lines of code, using 10,000 variables in JSFX. It was actually 10,000 times 200, so it was more than I promised in the title. And we're going to have to upload that audio sometime. Yeah, prepare it to sample, look back for a horror movie. Fun stuff. Yeah, right. So tomorrow I am maybe going to stream with Aria over here on the channel. Aria is back, but maybe I'm just going to continue with this. We'll see. I see you at the same time tomorrow, 6:30 UTC. and we'll do more of REAPER, either programming for REAPER or using REAPER, which is, I guess, the most fun thing you can do in REAPER is to program for REAPER and optimize the workflow instead of working, right? So doing all of this is fun too. So, right. So tomorrow, another stream, maybe about audio production, maybe about more of this. See you all tomorrow. Bye. Thanks for being here. Thanks, Bo. Thanks, Fortis. Thanks, everyone else. Goodbye. See you tomorrow.